So we're looking at section 6, and this section is we're going to work on it today and tomorrow, and even some more stuff later in the week is going to come from this section. So let's take a look. Atoms and elements. Think about how many words are in the English dictionary. All of these words were formed from only the 26 letters in our alphabet. In a similar way, 3 particles form the many kinds of atoms that make up everything around you. Parts of the atom. Each atom contains 3 kinds of particles: protons, neutrons, and electrons. A proton is positively charged. A neutron has no charge and is similar in mass to a proton. Both protons and neutrons are found in the tiny central part of an atom called the nucleus. An electron is negatively charged and has much less mass compared to a proton and a neutron. Electrons orbit the nucleus much like planets orbit the sun. Frankly, all that stuff in that paragraph is all things that we're going to need to know, and we'll summarize that in our note here shortly. And really this paragraph too. These 2 paragraphs are very important to us. The number of protons and electrons in an atom are equal. The positive charges of the protons and the negative charges of the electrons cancel each other out, making each atom neutral, neither positive nor negative. Table 1 summarizes some important information about each kind of particle found in an atom. We use atomic models to show the number of each kind of subatomic particle and where it is located. Figure 1. We're going to be drawing some of these pictures tomorrow. Electron orbits. As shown in figure 1, electrons are located in orbits outside the nucleus of the atom. The first orbit can hold 2 electrons. It can hold up to 8 electrons. The third orbit can also hold up to 8 electrons. This is going to be our lesson tomorrow. We're going to delve more into that. And this table is fairly important. We'll summarize that too in our note here in a bit. So really what we've discovered is we've got an atom, and inside an atom we've got 3 subatomic particles: your protons, your neutrons, and your electrons. So what happens is different types of atoms out there have different numbers of these particles, and that's what makes them different, essentially. So the importance of organization. If we put things in a logical order or organize them, it is easier to find those things later. Imagine looking for an item in a grocery store where items are arranged in alphabetical order. Pickles would be next to popsicles, and lettuce would be next to light bulbs. Pickles do not need to be frozen, and lettuce wilts if it's stored in a cool, damp place. So a different organizing system is needed. Putting groceries in order by the type of item and the type of storage they need makes more sense. Figure 2, well, obviously. Organizing the elements. All matter is made up of elements. An element is a substance that cannot be broken down into simpler substances. Gold, copper, and oxygen are all common examples of elements. And we've been looking at the periodic table for the last couple of days, and there are all your elements that we know. Not a bad idea to grab a periodic table for today's lesson too. Each element is made up of one kind of atom. This is why gold has exactly the same properties no matter where in the world it is mined. Gold and copper have different properties because they are made of different kinds of atoms. You may recall that scientists often record data in tables. A table helps organize data so people can make sense of it. All the elements are arranged into the periodic table so that elements with similar properties are grouped together. Okay, more important stuff for our lesson here today. The modern periodic table. Elements in the periodic table are arranged in order of the number of protons in their atoms. This is a key sentence as well here. The number of protons is called its atomic number. That's another important definition for us. Each element has a different atomic number. Bullet point. Each element in the periodic table has its own box. In the box is the element's chemical name, symbol, and atomic number. If you just look down at this periodic table here, it doesn't really show all that information. Like if I'm looking at helium, it just gives me its name. It doesn't give me the atomic number. Just gives a symbol, actually. We'll definitely need a better periodic table than this one in the book. The first letter of every chemical symbol is a capital letter, e.g. N for nitrogen, and the second letter is a lowercase one, A. So it's kind of like you can tell where an element's short form begins and ends, because we're going to start putting these short forms together soon. Each row in the periodic table is called a period. These properties of the elements that are in the same period can be very different. So just looking at this one here, you can see these numbers on the left-hand side. These all represent the period numbers. So if I'm looking at period 4, we're talking about all these elements. Oh, it's hard for me to highlight. Potassium, calcium, scandium. These ones are all considered to be in the same period. And you can see as we go across, we've got some metals, and then that goes to metalloids, and then we've got some non-metals. So periods left to right. Frankly, periods not so helpful for us, but groups are going to be very helpful in a future lesson. The elements are also placed in columns according to how their electrons are arranged. Each column in the periodic table is called a group or family. Elements in the same group have similar properties. Within each group, all atoms have the same number of electrons in their outermost shell. So you can also see there's some numbers up top here. So you can see there's, well, look at this 2 above BE. This is indicating group 2. So all the ones underneath are all in the same group. So they have similar properties. So they might be reactive with water, or they might be very stable. But as you go down, they're all kind of similar. In fact, that's sort of how the periodic table was arranged. Remember in the video yesterday you watched, it starts off by Mendeleev. He has all these elements on cards, and he's sort of organizing them. And eventually he says, you know what, I'm going to organize them by how they react or how similar they are. And so that's how we end up coming up with these columns up and down here. Most elements are either made of metals or non-metals. They are separated by a dark line that looks like a staircase right here. Hydrogen is the only exception. Elements along the staircase have properties in between those of metals and non-metals. These elements are called the metalloids. So just a little bit more here. Chemical families. You know what, actually I think we'll leave this here because we're going to talk more about this stuff and these pictures in a later day. If you go down further too, there's like a gigantic picture of half a periodic table. It's almost, my computer finds it hard to load this. And it does give some pictures, and then there's the second half. And yeah, I think that's as far as we need to go here today. So let's grab, we went over a bunch of important things, so we need to summarize this. So this is probably a pretty important note. This is the kind of note that when you do the quiz on this topic later, you're going to want to have handy, and you're going to want to refer to it. So let's grab our writing utensils or typing, whatever you guys do. I don't really know. Nobody tells me. But just don't sit there and watch. Make sure you write something down so you can refer back to it. Okay. So let me get a few things up here for you guys to copy. Atoms are the smallest part of matter. And I want you guys to draw this picture of the atom as best you can. The rings might be a little difficult here, but yeah, do your best. We're going to label some stuff. So this is meant to be an atom. We could figure out which atom, but that's not important right now. Okay, so I want you guys to add a couple of labels. So sort of like kind of two sets of labels. So the first thing we're going to label is I'm actually going to draw a circle around all these balls here, okay? And we're going to call that the nucleus. One sec. I shut my pen off accidentally. Okay. Oh, man. The nucleus. And you can see there are some particles in the nucleus. We'll come to that in a second. Now, the other thing I want you to label here for starters would be these rings. So I'm just trying to trace over this one here. Well, that's terrible. Okay, these are called electron shells. Let's see, where should I write that? I'm going to write that over here. electron shells. So this one has like 3 shells, it looks like. So if I ask what 2 things make up an atom, I guess I'd be referring, you guys could say one answer could be, well, it's made up of the nucleus and it's also made up of electron shells. And then inside of the nucleus and inside of the electron shells, we have those 3 particles that was mentioned earlier. So the first one is, we'll say this blue dot right here. That's an electron. Let's label that electron. Here, I'll point to it as well. Okay, so that there is an electron. So this diagram has like 3 electrons in it. And electrons are found in electron shells, and they're just kind of flying around. Now we also have a couple of particles inside of the nucleus. Now, my best guess for this one, and I'll do it in red here, I guess, is the red ones are the protons. The protons, we'll put those in red. Protons. And we also have neutrons there as well. And we'll put those ones in black. So these 2 particles are found in the nucleus. Okay. We're gonna recreate that little summary table that we saw in our textbook. We'll do that in a moment. I'll give you a sec to get this down here. Okay, so okay, moving on here. So here's what we're gonna say. We're gonna say atoms are composed of 3 subatomic particles. So I should mention, like, as scientists, if you take any kind of matter, solid, liquid, or gas, and if in theory you're able to zoom in on it as far as you could go, the last thing you could see would be an atom. Okay, now we're talking about things that are inside of the atom. Scientists have never seen inside of an atom. We don't factually know that they're made of protons, electrons, and neutrons. Like, we don't know for 100%, but it's like every experiment ever done has sort of proved that these particles exist. So even though we haven't seen them, we're saying that they exist. We're saying that, yeah, they're there. And you know what? They're like 99.999, like they're there. They're there. That's what we're going to go with. So again, it's just a theory, but it's pretty much one that's basically confirmed. So let's make a little table here. Let's go 3 by 4, I think should do it. No, wait, that might not, hang on a sec. That might not be enough. 1, 2, 3. No, that's no good. Let's go 4 by 4. Oh, my bad, sorry. Oh, that's better. Okay, 4 by 4 here. So we're going to put, I'll make this bigger in a second here, particles. And in no particular order here, we'll do the proton first. We'll do the neutron next. And then we'll end with the electron. And I'm actually going to shorten those 2 columns. I'll leave the last column a little bit bigger. Okay, so that bigger. And I'll tell you what, I'll just do the rest of this here. So we'll have symbol. short form charge and location. Okay, so again, I'll give you a little bit of time here to get that. There we go. I'll give you 1 minute to make your tables. And there's a minute. Okay, so let's start filling this in here. So we got a proton. In the future, instead of writing the word proton, I'm just going to use the word P. P for proton. Proton, P positive. That should hopefully be easy to remember, if I can type it. Okay. And remember from that picture we just drew, if you look back at it, they are found in the nucleus. Protons found in the nucleus. Okay, good enough. Found in the nucleus. And yeah, neutrons. Instead of writing the word neutron, we're just going to put N for neutron. And these don't have any charge. So how about a charge of 0? Or no charge. I don't know. They're neutral. They don't have a charge. And these are also found in the nucleus, according to our picture. Okay. So they are together there in the nucleus. And then we have our electrons. And these electrons, you know, they're not found in the nucleus. And they have a symbol of E. And they have a charge of -1. By the way, that was positive. I guess I could have put +1, -1. They're meant to balance each other out. And these are found in electron shells. Found in electron shells that orbit the nucleus. I'll make that smaller so you can see it. That'll work. So found in electron shells that orbit the nucleus. So again, this whole column you could have just figured out from looking at that picture we initially drew. Now I do want to investigate these particles a little bit further. I've got a little bit to say about a few of them here. So let's pop forward here. I want to talk about protons. Okay, protons. And again, hopefully you guys have already grabbed a periodic table. Make sure you got one. Protons. These are different for every element. So it's kind of like the fingerprint. It's how we figure out what element we're talking about is by the number of protons it has. I think that's such a good way of putting it. I'm just going to put that in brackets. Fingerprint. Hopefully that reminds you that it's a little bit different here. It's different for every element. So let's do a couple of examples, and hopefully you'll get the picture. And again, hopefully you have a periodic table handy. How many P's does or do the following have? Okay, so a couple of these and you get the point. Let's do lithium first here. Lithium. Or just Li, whatever you want to put. Now, how the heck are we going to know that? Well, this is where our periodic table comes in handy. So, if you've got a periodic table, and let me just grab one here. I know I've got one somewhere. Oh, no. Just give me a moment. Okay. Periodic table. There it is. So all we got to do is find lithium on here. And it's actually, it's kind of near the start. It's right here. There, it's right. Lithium is right here. So there's some important information in this box. The first thing we need is this big bold number there. It might be a little hard to see on my small screen, but it's number 3. And guess what? That tells us how many protons that lithium has. That number, and it's called the atomic number. And this is how our periodic table is arranged. So you can see hydrogen is number 1, helium's number 2, lithium's number 3, beryllium's number 4, 5, and so on until we get way down here and we have 118. So that's how you tell how many protons an element has. You just got to find its symbol and figure out which number it is. So if I jump back to that previous slide here, we can answer that lithium's number 3. So it has 3 P's. And if we say did another example here, Ag. So capital A, small g. So that's silver. So silver is Ag. Sometimes the symbols and the names don't match up. And that's because some of them come from Latin, which is a language that apparently were using a lot 500 years ago. And so some of the elements' names have a Latin name. If we go back to our periodic table, we just got to find the symbol Ag. Right there. So it's number 47. So it has 47 protons. Just that simple. I mean, yeah, it's a bit of a pain to find these things, right? So this one has 47 protons. So the point is here that if you find an element that has 47 protons, it's silver. If you find an element that has 3 protons, it's lithium. That's how we tell them apart. If you travel to another dimension where they had particles and you found something that had 47 protons, it would still be silver. So there's an important term we use. It's called the atomic number. And that tells us how many protons there are. And this was a definition in our textbook. So the atomic number tells us the number of protons an atom has. Something was said. I'm going to underline the term atomic number here. It's super important to us. And as I said earlier, our periodic table is organized by atomic number. Destiny, if you got to leave in 5 minutes, that's fine. I'll post the lesson later on, and you can complete the work and check your answers there also online too. Okay, so I think that's all I have to say about protons. A little bit more here about neutrons and electrons. They're important to us, but maybe slightly a little less important to us in grade 9 anyway. So neutrons let's see here. So neutrons are important to us in one particular way, and that way is that neutrons and protons make up all the mass of our atom. So I'm going to say this. So we already know they're found in the nucleus. So I'm going to repeat that, though. Found in the nucleus. I spelled nucleus wrong there. Found in the nucleus. Together with protons, they make up all of the mass of an atom. So these two particles together make up our mass. Now this is an important point because we've got a second number that we're also interested in on our periodic table. And that's called the mass number. So I'm going to mention something about the mass number here, and then we'll come back to it. So the mass number of an atom is made up of protons and neutrons. So the mass number is also an important definition. So atomic number and mass number. We're gonna be using both of those here in a little bit. So let me again grab a picture of our periodic table. Actually, we can just go back to the other one. I'll come back to this slide here. Okay, so once again, looking at our box, I'm going to go back to lithium as well here. So lithium's number 3. Now, its mass number is posted in the right-hand corner, and it is 6.94. So for our purposes today, we're going to be rounding these decimal numbers, and if you look at other mass numbers, they're all a decimal number. We're going to be rounding them to whole numbers. So 6.94 will round up, I guess, to 7. So you either round up or you round down. And again, every element has, at least on this periodic table, its mass number in the top right-hand corner. I don't know if you can read them after I write over top of them, but you can see they're all decimals. We'll explain that to you in another course. For now, we just want to round them. Right? If you're not using this periodic table, make sure you understand which number is atomic and which is mass number. The mass number is always bigger because it's made up of 2 particles here. So let's say this here. Let's say one other thing. To find the number of ends that an atom has, we need to subtract the atomic number from the mass number. We'll do that here in a second. I guess I had a lot more to say about neutrons. So to find the number of neutrons that an atom has, you need to subtract the atomic number from the mass number. So let's do that. So example. How many neutrons, how many N's does lithium have? Again, hopefully you guys like all the short forms I'm using. N for neutrons. We can use the symbol Li. I mean, that's for lithium. So as long as you understand that there's a couple of numbers on the periodic table that we need, it shouldn't be too bad to answer. So our lithium, we know two things about it. We know it has an atomic number of 3. And it's got a mass number of 6.94 that we're going to round to 7. So this becomes the two numbers that we're going to subtract. So it's always the bigger one minus the smaller one. And that gives us our neutrons. Bigger minus smaller. So now that's all I have to say about neutrons. And just a couple of points about electrons we'll talk about. Electrons are going to be much more important to us in grade 10. They're kind of important to us right now. In the scheme of chemistry, they're super important, but we're kind of playing down their importance right now. So let's wrap up our note here. Well, sort of wrap it up here. Talk about electrons. And just a couple of points here about electrons. We're going to say that the same number of electrons as protons in an atom. So let's say the number of E's in an atom is the same as the number of protons. So P's and E's are the same. And one other statement too, and this is going to seem kind of weird. We say that electrons have no mass. Because we say our mass is made up of protons and neutrons. We actually say the electrons don't contribute any mass. Now, I mean, they do have a kind of a tiny bit of mass, but it's all sort of relative. So just to give you an example, let's say you're sitting in your house right now, and the question was, what is the mass of your house? So whether or not you're in the house or not, the mass of the house isn't going to change with any significance. You know, if your house, I don't know what a house weighs, we'll say 10 tons. You know, if I ask how much your house is, it's probably 10 tons whether or not you're in it. And that's what we're saying about these electrons, is they have such a little mass compared to the protons and neutrons that they just don't matter. All right, let's wrap this up now with something important. It's just a way for us to organize our information. And start a new slide for this. It's called standard atomic notation. For sure, for my, sometimes I just put SAN, standard atomic notation. And all it does is it just shows the particles. It's just a way of taking that info on the periodic table and writing it down on paper. In fact, and it's got the mass number, it's got the atomic number. Let's just look at a couple of examples. So we've already looked at lithium here. Let's do lithium again. All right, so let me put it right. Okay, so there's lithium. So the first thing you need is a symbol. Okay, lithium done. The second thing you want to do is you want to put your mass number up top. And the mass of lithium is 6.94. That will round to 7. So that's our mass number that we've already talked about. And then the second thing you want to put is right below it is the atomic number. And then we want to list the info, like how many protons, electrons, and neutrons does this thing have? So this is where, if you're not sure, back in your note and you realize that this number here, the bottom number, tells us our protons. It's our atomic number. So this thing has 3 P's. So these would be the same. And as well, too, we've been talking about the electrons being the same. So it also has 3 E's. So like all 3 of those numbers are the same. The atomic number tells you how many protons. It tells you how many electrons. And the last thing is the neutrons. And I guess we already sort of did this for an earlier example, but we said to figure out the neutrons, all you got to do is take the bigger number, the 7, and subtract the 3, and you get your neutrons. I wouldn't mind one more example. Again, I hope you have that down. Let's do the standard atomic notation of fluorine. Like, let's just put fluorine underneath here. You don't need to write anything more. So fluorine. So grab your periodic table and let's figure out which number on our table fluorine is. If somebody finds it, you can type it in the comment section. What number is fluorine on our periodic table? Has anybody found it? Is anyone still awake out there? Anybody? Anybody? Type it in the comments. You don't need to say it. What number is fluorine? It's on the right-hand side of the periodic table, kind of near the top. Well, somebody said something. 9 is correct. Kiana, you rock. It is number 9. Number 9. And we'll put that smaller number on the bottom. And immediately that tells us that we have 9 protons and 9 electrons. 9p, 9e. Remember, those are going to be the same for you guys today. Now that we've found that's number 9, we need its mass number. And probably on your periodic table, it probably says it's like 18.99999. Okay, so it's 19. We'll round that to 19. And then those are the 2 numbers we'll subtract. 19 minus 9 gives us 10 neutrons. Bam, bam, bam. There are our 3 particles. So we have one worksheet that I want us to do here. So go back to the website and I'll open it up myself. Here I go now. It's located right here. By the way, right underneath it are the answers. I'm still getting people asking me where I hand work in. We're not handing this work in. You do the work as a warm-up, you check your answers, and then we're going to have a quiz on it. So like if the quiz is the game, then this would be the practice for the game. So let's open up the standard atomic notation worksheet. If you can, again, there's multiple ways to do this, I guess. You can download it, you can open it, you can write it on paper, kind of whatever works for you. I don't know what works best. I'm starting to feel like, because I have this fancy pen that I can write on things, that maybe it's not a bad idea if I was you guys, if I would just sort of write on it and save it with me writing on it. So I did the first one for us here, aluminum. And I'd say kind of the key part here, kids, is the standard atomic notation part. Is this column here, right? It sort of tells us everything. So you can see that for our purposes, our atomic number 13 is going to be the same as our number of protons and number of electrons, okay? I've also indicated for this example the mass number, and then that's why we're subtracting those 2 columns to get our neutrons. So we can do, I don't know, I'll do the first one with you guys, and then you guys can get to work and give it a go. and then check your answers later, and that'll be all we're doing today. So let's do argon together. It's on the far right-hand side. It's in the very last column on the right. I think if you find it, it will be marked as number 18. So that is our atomic number, 18. And as indicated above, these columns are going to be the same. So that's also 18. That's also 18. There's also an important number in that box. It's mass number, 39.95. We'll round that one to 40. And then that 40 and that 18 become what we're going to make our standard atomic notation out of. A little hard for me with this pen to do it, but you put the 18 above, sorry, you put the 18 on the bottom, the 40 on top, and you write its symbol AR. And then those become the two things we're going to subtract. So let's see here. We're going to have 40 minus 18. Grab your calculator on Google if you want, but that's going to be 22. And that is how you do it. So I think tomorrow, after tomorrow's lesson, we're going to have a quiz on this stuff. And so, I mean, some of the typical questions are, you know, like how many protons does oxygen have? How many electrons does oxygen have? You know, how many neutrons does oxygen have? Or apply that to any other element. You know, where do we find the mass of all atoms? You know, what two particles are they made up of? Those are sort of our takeaways here. Okay, so I want you guys to spend, and you can log off. You don't need to work online here. You can basically fill this worksheet in and then double check your answers. Make sure you're doing it correctly. Tomorrow's lesson is going to build on today's lesson, so we need to make sure we understand this. So I'll stay online here. I'll stay online if anybody has any questions, but like I said, you guys can work offline. Just make sure you understand how to do this, please. And if you got any old quizzes that need to get done, do those as well. Make sure you're caught up. I think we've done 2 so far. Any questions here? Excellent. So let's get to work here. And like I said, you can leave the meeting. I'll stay here if you want to come back and ask me for some extra help. All right. That was a long lesson. That was a tough one. That's probably